So that's our first two functions. Now let's look at some of the trig functions. We have your typical sine, cosine, so sin, cos. We have tangent, which is tan, pretty much as you would expect. Again, you can see here I'm using the variable pi that's built in. And note that sine, cosine, tangent, sin, cos, and tan are always expecting input in radians. Right? And so next thing you might want to know is how do you do the inverse sine, the arc sine? Well, conveniently there's a function, a-sin for arc sine. So, and the other trig functions are exactly as you would expect, a-cos, a-tan, and so on. But now what if you wanted to do the trigonometric functions of angles in degrees? Well, you could just convert the radians to degrees, or you can use these functions sind, cosd, tand, and so on for basically the sine in degrees. The d is for degrees. Okay, so there's trig in MATLAB. You can do logarithms. So if you say log 5, what that's doing is taking the natural logarithm base 5. Right, and so natural logarithm is base e. And so you might be wondering, like, isn't log usually base 10? Well, in high school, log is usually given as base 10 when you just say, I take the log of something. In college, in pretty much all your science, math, and engineering classes, when people say take the log of something, they're referring to the natural logarithm, the logarithm base e. If you want to take the logarithm base 10, you have to specify that with the log 10 function. So note, logarithm takes logarithm base e, the natural log. Okay? And one other thing you might want to know is how to raise things to powers. There's a function for when you're working with the variable e. Really, and now we're looking basically the opposite of natural logs. If you want to take e to some power, you can use this function exp. It basically stands for e to the x power, exp. So exp5, as we see right over here, gives you the variable e to the 5th power. So now let's look at some more functions. Right? We have the REM function, which does not refer to any indie rock bands, but rather refers to remainder. REM's for remainder. So if you say REM 15, 2, that gives you the remainder had you divided 15 by 2. So it would give you 1. One important thing to know, and really an important thing to realize, is here I'm not saying 15 divided by 2 in the inputs to my function. I'm saying 15, 2. Right? So why is that? So if I said remainder of 15 divided by 2, what that would do in MATLAB is it starts evaluating from the inner parentheses first. So it says, okay, what's the remainder of 7.50, and so on. Okay? And MATLAB looks, what's the remainder of 7.50? And it says, that doesn't make any sense. 7.50 doesn't have a remainder. You're not dividing anything. That's why MATLAB needs it as commas. It needs the numerator and divisor as separate inputs to this function. So you always have to say 15, 2. So don't forget that. Some of you guys who've programmed before or done math before might be familiar with the mod function for modulus. Notice the modulus and the remainder function are quite similar, but once you start getting in negatives, it starts doing slightly different things. For the purposes of this class, whenever you're working with remainders, you'll probably just need to use the REM function. So don't worry about the modulus function if you haven't seen it before. If you have seen it before, just try it, where one, both, and then alternating of the numerator and divisor are positive and negative, and you can see the difference. Okay. Other pretty simple functions that are built in, there's a sine function, sign, and that just returns basically whether x is positive, negative, or 0. Sine x returns 1 if x is positive, negative 1 if it's negative, and 0 if it's 0. Okay. Now we'll look at a couple more math functions. You can factor numbers. The factor function returns the prime factors of 15. Okay, and so let's look at some examples of that. So if you factor 15, it'll give you 3 and 5. Those are the prime factors. If you factor 8, it gives you 2, 2, and 2. Those are the prime factors. Okay, and recall that the prime factors are basically prime numbers that when you multiply them together, you get 8 or you get 15. Okay? Notice that's it's not giving you all possible factors. That's a much different problem. Okay? So let's switch back to the PowerPoint. GCD and LCM return the greatest common divisor, least common multiple, respectively, as you might guess. To take the factorial of a number, you use the factorial function. Notice that if you type 15 exclamation point into MATLAB, thinking that's a factorial, it's not going to work. Okay, so always use the factorial function. All right, and so that actually gives us one other thing I want to point out. Saying the answer is 1.3077 e plus 012. Right, so 1.3077 e plus 012. And so that is in scientific notation. This e has nothing to do with the math variable e, the math number e. That just basically means times 10 to this power. So this is actually 1.3077 times 10 to the 12th power. So it's giving it in scientific notation. The way you can play around with that is using the format command in MATLAB. You could say something like format, I believe, long, and it gives you basically higher precision. If you type help format, it gives you all of the different options that you can use for displaying things. Right? All right. And so the other functions other than factorial I want to introduce are primes and isPrime. And so these are two functions having to do with prime numbers. So primes, what it's going to do is give you a list of all the primes less than or equal to the number you give as your input. So primes 15 gives you all the primes up to 15. However, isPrime tells you true or false whether or not it's a prime number. So is 15 prime? No. Is 13 prime? Yes. All right? So just keep in mind the distinction between those two functions. And then we have a whole bunch of rounding functions. We can round in more ways than you'd ever imagine. Right? So the round you're used to is, if you're 0.5 or greater, you round up. If you're less than 0.5, you round down. Right? And so that's implemented as round in MATLAB. And you'll notice, so if you have 5.3, you round down. If you have 5.6, you round up. And if you have negative 5.6, you round towards the greater magnitude. So you round towards negative 6. A new function that you might not be used to is one called fix. And what fix does, it rounds towards 0, which is effectively you chopping off the decimal. Right, so if you think about it, you have your number line. If you're rounding towards 0, and you're between 5 and 6, so 5 point something, you round towards 0, so you round to 5. Right. If you're between negative 5 and negative 6, and you're somewhere in between, you round towards 0, so you round towards negative 5. And of course, that would have been negative 5 point something. So fix chops off the decimal, right? Remember that.